Welcome, everyone. It is 5 o'clock on the West Coast, so welcome to the Thursday, April 18th edition of the Vancouver Power BI and Modern Excel User Group Meetup. Today's topic is slide into data using Python and Excel. Well done, Joseph. Here we go. Let's jump into the normal stuff that we take care of here. Today's meetup, we're going to be doing a quick welcome and overview. At around 5:05, we'll be jumping into the what's new in Power BI. And then we'll get into the feature presentation at around 5:20-ish, depending on just how long Joseph decides to spend on the first of his two presentations for tonight. So, as always, I want to say a big thanks to the sponsors. Skillwave.training is the training company that I run with Matt Allington, where we focus on teaching people how to build better data models and how to build great DAX solutions in order to build business intelligence for your organization. Excel Guru is the parent company of Skillwave and also the distributor of Monkey Tools, an amazing tool that works in Excel that will help you build better data models faster and just generally be more efficient in Excel. Our next meetups that we have coming up, our next meetup in 2 weeks, we've got Tom Hinkle is going to be joining us. He is going to be building an epic Minesweeper adventure in using ChatGPT in Excel. So this is going to be kind of interesting to see a little bit of AI play and going in with some games in Excel. So I'm very much looking forward to that. That will be at 5 p.m. Pacific on May 9th. And our next Power BI track, we've got Michael Olafusi is going to be joining us again. It's been a while since we've had him here, and he's going to be doing a demo on Power BI and Git integration. So that'll be kind of an interesting one as well. If you know anything about Git, I use Git for managing Monkey Tools backend for coding. I have not used it with Power BI, so I'll be looking forward to seeing what Michael has to share with us there. Couple things new in Monkey Tools. Apparently I didn't check my animations on this. So let's talk about the last thing first. There is a new series of using Monkey Tools videos that is now available on YouTube. You can find it at the short link. This is the direct address that will reroute you to the YouTube playlist. This is something that I have got a lot of questions from people over time is, hey, when are you going to give us something that actually teaches us how to use this? So this morning we uploaded the first 8 videos of this playlist. The first 7 are all about the sort of key background info, and the 8th video is how to use the from table or range monkey to get a better from table experience in Excel. From this point forward, we will be posting 1 YouTube video per day, Monday through Friday, onto that YouTube channel. So there'll be new content every single weekday. And right now, well, on my list right now of videos, there's about 60 altogether that I have on my list. So there's going to be lots of content coming in the next future while about how to use all of the amazing features that we built there. As far as what's new in the software itself, one of the biggest things here is that we added a new pro user feature in Monkey Tools earlier this month. This is one of those things that always drove me crazy is if you had a table that you had in Excel and you pulled it into Power Query, if you renamed the table, your Power Query broke. So that doesn't happen anymore because Monkey Tools auto updates your Power Query as soon as you rename your table. So we actually take care of that thing for you right away so that you don't end up with broken Power Queries when you're doing the table rename. Should you decide that you want broken tables, you can also disable that option via the options monkey. Not sure why you would, but you can. So there you go. We also have a new purchase option. For the last 2 years, people have been asking me, hey, Ken, can I just do a one-time purchase of Monkey Tools? So we now have an option to purchase a lifetime pro license. If you don't like subscriptions, you can go and check that out. And as always, there is a variety of bug fixes and polish and user interface things that we've been dealing with to try and make your journey a little bit easier. If you haven't tried out Monkey Tools, there are free and pro trials of this thing. Check it out at monkeytools.ca. I think, as you start watching through some of these videos, hopefully you'll see that it's an amazing tool, a lot of feature capability available completely for free, with even more available for pro users. So definitely check it out. The next semester of my Excel Fundamentals Bootcamp kicks off on May 8th. If you or someone in your organization you feel should get some Excel training to fill in some knowledge gaps and learn about pivot tables, data visualization, and Power Query, really sort of master some formulas, you should definitely check out this program here. There's about 30 hours of training and coaching goes into this. You get access to my Ask Ken live sessions that we do every couple of weeks. So that's a 2-hour live session with me on Teams where you can ask questions about anything, and I will help you out with those things, help you build your solutions, get access to the whole archive and whatnot. There's a lot of benefit for this. If you're interested, you should definitely check out the program. As I say, the next semester of this starts on May 8th. If, on the other hand, you're already a pivot table wizard and you want to really upskill your game in Power Query and Power BI and Power Pivot, this is where my self-service Business Intelligence Academy comes in. There's over 40 hours of prescribed coach or training that is going in through this one. Actually, we're going to be releasing another hour and a half of content next week. That is going to be around optimizing SharePoint from folder solutions to actually make them work a little bit faster than what you probably are used to. These also have access to my Ask Ken archives and sessions. It's got access to our forums, a copy of my books, all things, including a Monkey Tools Pro license subscription for the entire time that you are subscribed. So if this sounds like something you're interested in, you should definitely check that one out as well. Once again, the next kickoff for this one is also on May 8th. This meetup, as all of our meetups, is recorded and will be hosted on the Skillwave YouTube channel. I will be posting this meetup sometime tomorrow once it's all done. Got to get it done early because I'm off to Bulgaria next week for a conference, so definitely got to make sure that's out the door. Once that is actually released and on the YouTube channel, we will send a notification through Meetup so that you will actually get notified of it. If you've already joined in the meeting, you'll hear all about it right away. So. Couple of things as well, just on Monkey Shorts. These are different than my using Monkey Tools videos. Just some quick tips around working with software and Excel and whatnot. Copy paste history with Windows V. This is one of my favorite tips for working with Windows. You should definitely check this out. I think you'll find this will actually save you a lot of time when you're copying and pasting, and even allows you to work across multiple computers, which is pretty cool. And also some Power Query filtering tips. So a couple of different Monkey Shorts video, less than 3 minutes of technical content end to end in every one of these. The last thing that I'm going to say before I turn it over to Joseph here is if you are interested in coming and presenting to the Vancouver Power BI and Modern Excel user group, we would love to have you. Just fill out this form right here. By the way, all of these slides are already up on the Meetup site, so you can grab all those links right there, but just fill in the form. We'll get in touch with you. We'd love to have you on our stage here. We're open to talking about anything with Excel or Power BI or anything in the Power Platform that ties into those technologies, and we're always looking for new speakers. So, and on that note, that's it for me, Joseph. The floor is yours, my friend. Are you ready to talk a little bit about what's new in Power BI for this month?
I'm ready to rock.
All right, let's do it.
Cool. All right. So yeah, thanks Ken for the introduction. Hello everyone. As Ken alluded to earlier, I'm doing both the What's New in Power BI as I do every month at the user group, and I'm also doing the feature presentation after. So I think we're going to have a bit of a shorter What's New in Power BI, a little bit of an abridged version for the April feature release, and then we'll jump into Python integration in Excel. So I'll do the About Me part ahead of the feature presentation, I think, and I'm just going to jump into what's new in Power BI for this month. So like every month, the place where I like to start is the Power BI feature summary blog for the most recent month. We actually had an early release, or a release early in the month, I should say. We see April 9th. So it's been out for, as I said, about a week and a half. So a nice long run up in time to prepare for what's new in Power BI. So I'm just going to highlight a few quick things, a few of my favorite things, as I say. But if you want to see a full comprehensive list of all the new features in Power BI, be sure to check out this blog post. We have some reporting updates, which I'll be getting into in just a moment, some connector update with the Snowflake data connectivity, lots of updates, or storytelling in PowerPoint, rather. I covered some of the updates to that last month. Further updates have been made, and then we have mobile visualizations, etc. But the two reporting feature updates that I want going to look at first are these top two in the reporting section. We're going to look at a new visual, a 100% stacked area chart. This is a new native visual in Power BI. And we also have line enhancement. So for actually both our line and our area charts, we now have more control over the formatting of these types of charts. So I'm going to start with these two. Let's jump into Power BI, and then I'm going to come back and just highlight one more of my favorite features. But let's head into Power BI to start. So this is my demo file. If you've been to any of the other user groups, this will be really familiar. This is what I use to demo some of the new features. And as we can see in the top right-hand corner here, we have a really basic area chart, where we're just looking at the mean or the average balance over time. And if I expand my data pane to the right, I can drop on a different column from one of my dimensions to be the legend of this area chart. So if I take like segment name, for example, and we see I'm using the area chart. So all of these areas are actually overlapping with each other. So previously, what we could do is what's known as a stacked area chart. And now we can start to see that like segment 1 is a really small area, and stacked on top of that is segment 2, then segment 3, and segment 4. And we also have this idea of stacking in our ribbon chart, which is like an ordered stacking, if you will, and as well in our column and bar charts. But one thing that we've had in bar charts, but we haven't had in area charts up till now, is this idea of like relative stacking, if you will. We want to know what percent of total do each of these segments contribute to. And we now have this 100% stacked area chart. So we can see that the first 3 segments, segments 1, 2, and 3, add up to about 50% in total. And then segment 4 is contributing from 50 to 100%. So this is how we can see not the actual balance as it's trending over time, but relatively how each of these segments is contributing to the total over time. So this can be really good for context setting on a Power BI report. Typically, I would use this alongside those raw numbers that we saw before in either this view or this view. But it's good that we have the option natively in Power BI now to not just use like 100% stack chart like this, but we can also have an area chart over time as well. So that was the first update. The second one is more control over our line chart. So I'm going to switch this visual to be a line chart as well. And now if I open up the format pane, I'm just going to collapse some more panes down. If I open up the format pane, under this line section, we now have some additional formatting options. So we can apply these settings to all lines, so for each of our 4 segments, or if I want to, I can just apply formatting to a single line, which is pretty cool. Like if we just want one of these 4 segments to stand out in our report, we can, if we wanted, I don't know, segment 3, let's say the orange one, we could update some of the formatting just for this. Like we could change the line style to dashed or dotted, and some of these things we've had before. But we can also change to, the different join types, the width as well. Well, let's go back to all. And for our type of line, typically, and since Power BI came out, we've always had this linear option. But more recently, we've added a smooth option. It's difficult to see in this example. Maybe we can update this one over here to the left. Here we go. When we have a smooth option, we go from the linear sort of jagged lines, or I think Ken's referred to this as the accountant view before. And now we have a nice, more smooth, sort of visually pleasing line. And we've also added step, which is kind of cool. I'm going to demo step on this one to the right. It might be a little bit easier to see. So rather than sort of a straight line from point to point, we're now stepping up to the next point or stepping down to the next point from center or before the point or after. We can decide when we step. And one of the new features, new formatting features for this month is the transparency. So if I wanted just for a particular line to increase the transparency so it's a little bit more faint, we can see that this segment 2, and we can do the same thing for segment 1. If we want it not to stand out as much, we can increase that transparency. They disappear a little bit, for a lack of a better term. They're still there on the chart, and we can allow us to like really highlight and focus in on one of the lines, which is pretty cool. So that was just a quick demo just to see the 100% stacked area chart, some updates to the line formatting. But just before I wrap up what's new in Power BI, I do want to focus on this introducing the Copilot pane in Power BI desktop. There's lots of different blogs and documentation around Copilot, particularly in Power BI, obviously all really throughout the Microsoft infrastructure. But within Power BI, Copilot is now available native in Power BI. There are licensing requirements, which I believe are covered in this blog post here. There's links to all sorts of blog posts. And if I go back into Power BI, it's now on the Home tab on the ribbon here, as well as sort of sprinkled all throughout. So I was building out a demo. Unfortunately, the tenant that I had that had availability to Copilot now is on a trial basis, which you can't use a trial SKU to showcase Copilot. But once I get that sorted out, hopefully next month I'll be able to demo some of the Copilot functionality, or at least write a blog post for it. So with that, I was going to say I'll send it back to Ken, but I guess I won't send it back to Ken. I can send it to myself and jump into the presentation. I will just close down all my Power BI stuff. Let's not save that. Get rid of the what's new and start. Before I jump in, Ken, anything from you, or am I okay to get started?
No, man, you're good to go. Absolutely, thanks.
Cool. All right, so still me, feature presentation. For the About Me, I would encourage everyone to actually check out my website, feathersanalytics.com. It's my website and blog. I'm doing a little bit of a revamp recently for my website. So it will also have the presentation, a little bit of write-up of the presentation from today. Some of the presentation files I'll get up a little bit later today. You can find that in my portfolio page under presentations. We see Python integration in Excel. But a little bit about me. As I said earlier, I often present at the Power BI or the Vancouver Power BI user group. I've been attending pretty much since the beginning, since 2016, I think, 2017 for sure, maybe 2016. And I think every year I've done at least one feature presentation, again, all of which you can find on my website or recorded on the SkillWave YouTube channel. And I present what's new in Power BI monthly as well. So really my passion is for Power BI, and as some of my previous presentations have shown as well, really integrating the power of R and Python more recently into Power BI. But today we're going to take a slightly different spin, and we're going to be looking at Python integration in Excel. So I'm just going to close that down for a second, and we can look at getting started with Python in Excel. So this has been out for, I think, definitely more than 6 months, 7, 9, maybe even as much as 9 months ago. Python has been available in Excel. This was huge news when it came out, that we don't need to use add-ins, we don't need to use workarounds. We can actually just use code Python directly in Excel. This was super cool. I've been playing around with it for a while, but one thing to keep in mind as I go through these examples, and if you want to play along at home or even just explore yourself after looking at the presentation, a few things to keep in mind. Currently, Python in Excel is in preview. So some of the things that I show, like some of the tips and tricks, if you will, it might change, they might disappear, and it might be fixed, or some of the functionality that I show might change as well. It's still in preview, so nothing is really concrete. And part of the reason for that is Python in Excel is currently only available on the Microsoft 365 Insider program in the beta channel level. So if we, on this Getting Started with Python in Excel documentation on the blog post, they do have links so we can see how you can actually sign up for that Insider program, how you can set your Excel to be part of the beta channel. I must warn you that it is really good that you get access to Python and you can play around with all sorts of cool stuff. But the beta channel, there are other parts of Excel that go into beta as well. So just be careful if you need a stable build, if you do rely on some of the features, just be careful going into beta. But currently, we do need the beta channel to go into Excel. Just thought I'd call that out at the beginning before I jump in and start showing some features. And it's like, why aren't these in my Excel? That's the reason why you need to be beta channel of the Insider program. So most of today, I'm just going to be going through a few different examples within my Excel workbook. okay, a bit of a rough agenda today. We can see from the sheets at the bottom. I'm going to start with some of the basics of using Python in Excel, like just what it looks like, how we can start coding with Python, and how we can access this functionality within our Excel workbook. Then I'll be moving on to how we can reference other aspects of Excel with our Python code. We're not just using Python independently. We can reference data in our spreadsheets. We can reference dynamic arrays, Excel tables, Power Query data, all sorts of stuff. And I'll cover how we can mix in Python code with all these different types of data structures in Excel. Then we'll move on to building Python visuals in Excel, what that looks like, how we can generate output and interact with it, as well. Sort of this section highlighted, I guess, by a user input controlled bullet chart. And finally, we'll build a classification model using Python in Excel. So we have some Excel data. We want to build a classification model. We don't need to go to Power Query or add-ins or anything like that. We can do all of that within Excel now, which I think is really cool. So I think for Ken, if you're monitoring the chat, that's sort of the breakdown, those 5 sections. If maybe we can pause after each one and just catch up on questions at that point, if that works for you.
Sounds good. Yep.
Awesome. All right, so let's jump into the basics of Python in Excel. So here in my spreadsheet, let's actually zoom in a little bit so it might be a bit easier to see. If I go to the Formulas tab on the ribbon, we have now in the middle next to our function library and next to our defined names, we have this Python in preview section. And so I'm clicked into cell A3 at the moment. If I go to insert Python, a few things happened. We see actually within the cell here, we now have this PY Python prefix. Our formula bar has updated a little bit, and this Python in Excel preview pane has jumped open to the right-hand side. So if I expand this a little bit, we do have some helpful links to help us navigate Python within Excel. We have, if we wanted to, we could start the tour. I like to think I'll be providing the tour today, so we don't need to rely on the built-in tour. But this is available to learn the basics, how we can use the Python formula to get started with Python, which I'll show in just a moment, how we can use the formula bar, access Excel objects, down and down. This all links to external blog posts that are available as well, and I'll have those linked on my website to help you get started with Python in Excel. I'm just going to collapse that for now. But one of the things that we can do just within Python in Excel, and one of the most useful things when it comes to using data in Excel is using data frames. So data frames is a tabular data structure, actually really similar to Excel data. If you think we have 2 dimensions, we have columns, we have rows, and we have data in the middle. And using Python or using pandas data frames in Python is a really similar experience. So this is how we can really integrate Python with Excel. It plays really well together. So I can just define a data frame. I'm going to use pandas, and I'm going to create a data frame. And rather than type everything out, I'm just going to copy some code, and then we can see what happens. So let's paste that in here. You'll notice that it's really hard to code with Python, just one line in the formula bar. So we can expand the formula bar using the keyboard shortcut Control-Shift-U, I believe, but we can also just expand it. And when I do that, we can see that we have nice IntelliSense when we're coding with Python in the formula bar, which is nice. But I'm just creating a really basic data frame, a pandas data frame, which we can refer to as PD. I have a grade column, a price column, a state column with some values in here. We also get this pop-up. We can use Control-Enter to commit our Python code, which is what I'll do. And once we do that, we see that we have a data frame object within our cell. So for anyone familiar with using dynamic arrays in Excel, this is a really similar experience. We can see that we have a complex data type within the cell. And if I hover or click on this icon in the left of the cell, we get this card preview. So we see that Anaconda, which is a distribution of Python. Anaconda is what powers Python in Excel. we see a preview of a 6x3 data frame here. We see our column names of grade, price, and state, as well as all the data that we've defined. So this is just a preview. And if we click on the cell, we see we have this, this option to add additional fields from this complex data type that we've defined in Python. So we can get a preview of our data frame. We can get like the type of the Python object we've created. If I preview the data frame, we see that we get a dynamic array here. The formula for this is we're referencing the data frame we defined, and we want to preview the array, preview that data structure that we've just created. I'm just going to delete that for a second. If I click back on here, we see just to the left of the formula bar, we have this drop down of what we want our Python output to look like. So I've outputted this data frame as a Python object. When I do that, this is when we see we just have this preview of our data frame, and we have some options of some additional information about this data frame we can add to our spreadsheet. I can also add this as an Excel value. So when I do that, it goes straight to just the data frame. This similar behavior as a dynamic array is what's added to our spreadsheet. I don't have the option to add additional columns. It's just this data frame that's added. So we have two different types of output. Throughout the rest of the presentation today, I'll be using both these types of output. And really, it just depends on your use case. Why are you using Python code in this particular cell? Do you need to have like a full output like this data frame? Or are we OK if I switch this back to a Python object? Are we OK just knowing that something is stored in that cell? As I say, as I go through the next few examples, it will become more clear as I go through. Yeah, so we looked at the different output types. We've created a single data frame in this cell. But if I go to a different cell, rather than going to the formulas bar and inserting Python, I can hit equals and type in PY for Python. And when I hit tab, we get that same behavior. I can now start coding in Python. I'm just going to paste in some another big block of code rather than sit and type it out. And let's commit that, and then we can dive in and see what that looks like. Oh, I think I did a little bit too much here. There we go, df1. All right. So in this cell, we see that we're defining a few different things, whereas previously we just defined a single data frame. Here we have a list of values that are generated using a range function. We're generating a new data frame, df1. Then we're adding some columns onto our data frame, and then we're referencing this data frame here. And if I preview the data frame, we can see some of the output here. And once again, we can toggle to see our Excel value. Let's recommit that. There we go. And we get a preview of this data frame. So we're defining a few different elements within this one cell. We're defining this numbers list. Then we create a data frame, and then we make updates to this data frame before wanting to look at it. So it's important to note that when we're coding with Python in Excel, if we do define multiple objects within our one Python statement in our cell, only the last one, or like the most recent one we did, the one at the bottom of our Python statement, is made available to us to output in Excel. We see that I can't output this numbers list. I can't output this original data frame. I can only output what we did in our very last step, is what's available to us at the bottom here. However, we can still reference these items in other cells as well. So if I pull up another Python statement and I start typing in that numbers list, we see that it's available to us in this cell. Like, we still defined it previously. It just was the first thing we did in that cell. Now it's the most recent one. And if I commit that, we see that we have a list. and I can output that as an Excel value, and we see we just have a list of 1 to 20. So this idea of creating multiple objects, we can still reference them, we can still use them, but just not within sort of the context of that cell, I guess. And when we reference them, we can also just do something like this. Like we can reference our df1, and if we want to look at all the columns in df1 here, we see the here we go. Let's change this to an Excel type. We can see all of our column names. That's available for us to use. So we can we have a lot of control over exactly what we can create and then what we can reference and output later on as well. So all of these are just sort of the building blocks of using Python in Excel. One thing to keep in mind, though, is when we do want to reference some of the objects that we create in other Python statements. So we can see that in cell H3 here, we're referencing the numbers list that we defined here in cell D3. Just like in a Python script in other environments, it runs sequentially. So Python scripts usually run from top to bottom. We've seen this behavior because only that bottom thing is available to us to output in Excel. In Excel, that is the same thing. It still runs sequentially. However, it runs sequentially from the first row, and then it goes across the rows in our Excel spreadsheet. It goes across all of the rows in our spreadsheet. It goes to the next row. It goes across. So it goes not only top to bottom, but left to right as well. And why this is important is if I take this, just this output of a list, and if I cut this and paste it in the row above, remember this was defined in D3, I'm pasting this into cell H2, I get this Python error, which, you know, if you didn't see enough different error codes in Excel, we now have a new one. We now have Python with an exclamation mark. And the reason we're getting this error is because everything that we can reference in this cell H2 is everything to the left of it in the same row and everything in the rows above it. We defined this numbers in this cell. So if I want to reference it, I need to have this Python statement to the right and below the cell somewhere. So if I put it over here, for example, it works because we define numbers in the row above it. So just something to keep in mind as we're going through like a multi-step analysis, everything needs to be either to the right or below if we want to refer to something that we created before. I'm just going to add one more step to this analysis. So I'll type in equals pi again. I'm just going to paste in one more code block. We can commit that. And now let's expand to the data frame here. And we can see to the right, we defined a couple more elements. We defined another list, our persons list. We did a for loop, which is kind of cool that we can use for loops directly in Excel now. We have this multi-stepped defining a condition as a list. We're referencing other things, and then we're updating our data frame that we defined to the left. So the code in this case doesn't really matter. It's really just to show we can define multiple elements within one cell. We can reference multiple elements within other cells, and then we can output this Python code in two different ways. We have a Python object that gives us the ability to output different information about this Python object, or we can output it as an Excel object, which is just the last data frame or data structure, like a list or a pandas series or a pandas data frame. The last one within our Python statement is available to us to output as an Excel object. So those are some of the basics. Some complex Python code that doesn't really have a particular use case in this case. That's what we'll be getting into in the next sections. But I know I covered a lot of ground and a lot of things that are probably new, that are new for anyone who isn't familiar with using Python in Excel before. So just before I move forward to the next bit, are there any questions in the chat, Ken, or am I okay to move forward?
You are okay to move forward, you bet.
Okay, awesome. All right, so let's escape out of there and go to the next section. Okay, so in the last example, everything that we did was in Python, right? Like we defined different data structures in Python, like data frames and lists and series, and we saw how we can reference them within a single Python statement, but also in other Python statements as well. And that's great. That's just using normal Python, essentially, right? Like we can do that in a Jupyter Notebook, in Visual Studio, wherever we code Python. Is like, why would we want to do that in Excel? We have other and probably more convenient development environments if we're only doing Python. So the reason we want to do it in Excel is because we want to interact with stuff that's in Excel. And so this is what we can do here. We have 4 common data types, or data structures rather, in Excel. We have just data that's in a spreadsheet. We have a dynamic array here. I will convert this to an Excel table in a second, and we have Power Query data. So I'm going to go through each of these 4 data structures to see how we can start using these and joining the power of Python together with these Excel data structures. So the first one, again, I'm just going to type in equals pi. This brings up my ability to use Python in Excel. And maybe the data frame that I want to use is this. It's just above here. It is this data that's already in my spreadsheet. I don't need to redefine and type out all of this information. I can just select it here. And when I do that, we see that we have this Excel function in Python. We see a reference to a range of cells, and we see an argument headers equals true. So this Excel function is what allows us to access data from Excel and bring that into Python, and then we can reference this and we can start manipulating it, visualizing it, creating predictive models on it. But it's this Excel function that allows us to reference Excel objects within our Python code. Here we see just a hard-coded range of values. It's the data that I just selected, and we see that it's also recognized automatically that we have headers equals to true. So when I commit that code, all I'm doing here is just referencing that Excel data. We see by default, if I zoom in a little bit, we see by default, this has been recognized and converted to a pandas data frame. So how I was working with tabular data in Python before, it recognizes tabular data as a data frame. And we have the exact same ability to add additional fields from it. We can see a preview of our data frame, which is just a replica of the data above. We can see our data just as string values. We can see the data type of our output, which is a data frame, and the type name as opposed to just type. So let me delete some of these things. And what this looks like as Excel output or an Excel value is just like a dynamic array. It's just a preview of this data. So just referencing Excel data, we see it's just that hard-coded range of values. What's cool is that we can also save this as something. So if I wanted to save this as like Excel data frame, I can now create a pandas data frame in Python using this. This is Excel data frame, like that. And then later on in my scripts, like further down in my Python statement, I can start manipulating this data, working with this data programmatically. And I'm not going to get ahead of myself. I will get into that later. But this is how we can reference just the most basic type of data structure in Excel. So moving on to our dynamic array, we can do really similar thing. So I'm going to create a dynamic array data frame. And this is going to be equal to all of this data here. And we can see that we get the syntax of a dynamic array in Excel. we see the cell that is the source of our dynamic array, F3, followed by the hash sign. This shows that I have selected all of that data in the dynamic array. And what's nice about using this method is that as our dynamic array changes or like updates in size or contracts, we're still capturing all of that data within our dynamic array or within our data frame rather. We're using the hard-coded values from our cells. If I added another column to this input data in like column D, or added additional rows, I'd have to remember to go into my Python statement in my data frame and update that to include the rows. So what's nice about dynamic arrays is that it expands and contracts automatically. So when I run this, we wait for a little bit and we get this calc error, this hash calc error. And I have to admit, when I was pulling these example files together, this stumped me for a little bit until I realized I've actually just discovered a tip or trick to share as part of the presentation. And the issue with this is I tried to be quick and just create dummy data using this rand array function, which is one of the dynamic array functions available to us. But Python functions in Excel can't reference these sort of like volatile data types. So rand is a great example of that. It's true, just the rand, the regular rand function or rand between in Excel, it's the same thing. Python can't reference these volatile data types, and that's why I'm getting this calc error. So since this dynamic array is created using rand array, I can't actually reference this with our Python function or within any sort of Python statement. What I can do instead is create a new dynamic array that will work. So I'm just going to use the filter function. I'm going to select just my data to the right here. And I just want a subset of this data. So I'm just going to say, okay, just return this data when the cost column is greater than 40. And now we do have a dynamic array, but it's not a volatile dynamic array. It's a stable dynamic array. So if I want to reference this with Python from just below, I can just grab the entire array here. Again, we see that same syntax. We see cell F16 is the source of the dynamic array. It spills out from there with that hash headers equal true. So now if I want to create a dynamic df, we can save that, we output that, and now we can see the preview. Here, we see that same preview, so now we can use a dynamic array as an input into our Python statement. So just need to be careful with the volatile data types, but dynamic arrays otherwise are totally fine to use as a input to our Python formulas to start using them together. Let's get that out the way. So now the most common one, or the most common data source for me, at least in Excel, like using more of the modern BI stuff, is an Excel table. So I'm just going to take this data, hit Control T to convert to a table. And would you look at that? We have the nice dialog box from Monkey Tools. Do I want to create a table? Do I want to create a named range? I want to create a table. I don't just have one or two options. I have lots of options. Ken didn't tell me to do this. I just hope I may. Oh, the heart emoji. Thank you, Ken. I am just going to leave it as table one. But we see our data does have headers. I don't want to create a connection in this case. I'm just going to leave it as is. But now we have a table. And one thing we can do, which can help speed up programming in Python and Excel, equal py to pull up. Instead of just sort of like clicking and dragging and dropping over my data structure, I can just start typing in this Excel function. And if I hit open bracket with a opening quotation marks, we see that this table one is available to us to reference. I just want Excel table one. If I go back to the start, I can call this like table data frame is equal to this. And now when I commit that, we see we have a data frame whose source was an Excel table. But rather than sort of, clicking and dragging across the spreadsheet. Since it's formatted as a table, I'm able just to type in Excel, what do I want to reference, my table, and I can go on with my Python script coding there. So that's pretty cool. Finally, we have our Power Query data type. Okay, so let's just collapse the formula bar for a second. If I go to the data tab on the ribbon and look at our queries and connections, I have a query which I've just left called query 1, just because I would remember what it was called that way. And we're connecting to data from the web. We've brought it into our Excel workbook just as a connection only query. But just to show exactly what it is, we see we have 180 rows. We just have 3 columns. We can see the load status of it. It's part of our data model of our workbook. So in a similar way, with Python, I can use the Excel function, opening quotes, and as well as our table, we have this query 1 available to us. If all I did was load it like that, we can see that we have a data frame, and this one I'm actually going to output as an Excel value, because if we go all the way down, we see that we have 180 rows. So we see from our query over here, 180 rows, connection only, but it's still available to us to use with Python as a data source to start doing stuff, which is pretty cool. And if I wanted to, I can totally update this and start doing like Power Query type functionality of data transformation, but with Python in our spreadsheet. So I can name this df Power Query. So all I'm doing is referencing that query. It's that query as is. But then further down in my script, I can start manipulating, and let's just do like a basic data manipulation of filtering. So I can take our data frame, and what I want to do is I want to take just this FSA column. So that's that first column from our query, and I just want to return rows that are equal to v7m as an example. So this is the Python syntax. What we're doing is we're saying, okay, give me the FSA column from our Power Query data frame where it's equal to VSM, and I'm using this statement to subset our data frame. And when I commit that, we see that we have just one row. We see we have like the headers from our query of FSA city and description, but we're only returning one row where our FSA is equal to V7M. So this is one of the use cases I think is really cool, is being able to use actual queries that we've created, not just data sources that are actually in like on our spreadsheet that we can see, but even data sources that are part of our workbook data model. Even if they're connection only queries, all that data is available to us to bring in as a data frame and then start manipulating with different pandas functions. In this example, it was just basic manipulation, just of filtering our data frame to only retrieve one row. But as I go through the next couple of demos, we'll see that we have more advanced functionality that we can use. But before I move on to the next section of visuals, Ken, are any questions in the chat?
Not at this point, nope.
Okay. All right. Just I take a sip of water. All right. So far we've looked at the basics of just how to use Python in Excel and some of the tips and tricks around that. Now we'll look to how we can actually reference Excel data for different common data types in Excel and bring that in so we can start using it in Python. One of the best use cases for using Python in Excel, I think, is data visualization. We just saw a basic example of data transformation. I have to admit, it is cool being able to do more advanced data transformation within the spreadsheet, like within a spreadsheet programmatically. I still default to Power Query, and I haven't found a great use case yet where I'd rather use Python in a spreadsheet for data transformation as opposed to Power Query or just a combination of Excel functions. I haven't looked super deep. I haven't been desperate to try and prove that Python is the better option. But when it comes to data visualization, and obviously more like predictive modeling as we get later on in the presentation. These are really the use cases I think that Python can shine. And I think I was told before I need to try and, why should I learn Python? Sell it to me. Why should I use Python in Excel? I would say data visualization, which are the next few examples, and some of the data modeling or predictive modeling rather, are the two main use cases I see of why you should make the effort to learn some Python to use in Excel. The data transformation stuff we can definitely get away with Power Query and existing Excel functionality, at least to a certain point. But the visuals is personally what I think is really cool. So let's start with just some basic visualization with Python. I'm not a huge fan of Excel visuals in the first place. I find myself having to use ChatGPT a lot, to be honest, to really try and like figure out what exactly what formatting do I have available to me to make my visuals look like they are. I'm being used to Power Query or using code like Python and R to make visuals. Excel visuals just frustrate me sometimes. I never know whether to put things on like rows or columns, or I try and switch them and it just like breaks it even further. But Python visuals I do think are quite simple, and you can make different types of visuals that are not available natively in Excel. So the first type of visual that I want to showcase is called a pair plot. So I think this plot is pretty cool. It's used a lot for exploratory data analysis with predictive modeling, because you can quickly see the relationships of a data set between columns, the relationships between columns of a data set, as well as the profile of columns within a data set as well. So I'm going to use a pair plot. The data that I want is just this little data set here. And actually, let's leave it at that for now. I'm just going to commit that code. And it's going to think. And we see that rather than a data frame, now we have this Python output of an image type. We can see a little bit of a preview of our image here when I click on the left of the cell to show the card preview. And then to the right-hand side, when I expand this like field options, we have a few different options now. And this first one, this action of display plot over cells, is actually new. I hadn't seen this until I started building out these demo files recently. This makes life a lot easier when it comes to interacting with this image. If I just click that, we see that we have a nice big visual created for us. Just automatically, it just pops out, it resizes. And what I like about this is if I take this column, if I just take this column and I delete it, we see that we have this refresh icon next to our image and our plot updates. So this image is actually connected live to our data. This Python code recalculates every time there's been a change in our spreadsheet, and this image stays connected to that Python data. It's not like just a static output, it stays connected. And so if I want to bring, let's undo that. If I want to bring that back, we see that our Python code starts refreshing again, and then our output is updated as well. So that's really cool. We can get to the same place as an Excel output as well. So if I click back on this cell, right now it's a Python output. I can change this to an Excel output. Changing the output type might break this image, but that's okay. We can always bring it back. And we see we actually get a little preview of the image within the cell. I know it's hard to see, but if I expand this cell like here and here, actually within cell G1, we as we've taken our Python code and we've outputted as an Excel data type, we have the actual image is in the cell there. Not very handy when it's a really, really small image like that. But what we previously could do is if we right clicked on that image, we could, where is the image? Excel value, where did it go? Not link. Okay. Oh, here we go. we would get this create reference option. I must have missed that on the drop down, but we have this option to create a reference, and this pops out that big chart as well. So previously we were only able to output as an Excel type, then create this reference, but now it's actually that is available to us as a Python output as well, which is cool. I don't need these two. I'll just go back to a Python output for now. Just as it refreshes. Okay, it's going to refresh again. Nice. And when I do this with the cards, we see that we can add just the image as opposed to that sort of related action. And with Python, we can also add just that really small image within a cell if we ever wanted to do that as well. It's recalculating. There we go. And we can also print off like some additional information because it's Python output, the size, the type name, the type, etc. So really cool. We can build that like a linked image that updates live to our data with Python. We can print off some additional like metadata stuff about it, and we can get to that same place whether we output it as an Excel value output type or a Python output data type as well. So I think that's really cool. This next visual demo sort of combines, goes a little bit deeper. Rather than just using a simple function to create a Python visual, we can also do some data manipulation with Python before creating the visual as well. And I think this really demonstrates the power of that Python and Excel integration. So if I create a new Python Python statement here, I'm going to use the I can use the Excel function, but I'm just going to grab all of this data here. So I'm essentially just creating a data frame, right? This is going to be a data frame from cell A1 to E11. And rather than just creating a data frame, from that data frame, I want to create a correlation matrix. So I can use this core function, which is available since we've converted our Excel data to be a pandas data frame. So I want to find out what's the correlation between all our numeric columns. So I just need to update the numeric only parameter to be true. And I'm going to, oh boy, let's pull that back. Okay, we create a data frame, we do a correlation, numeric only is equal to true. And if I click into the, let's commit that. And it thinks about it for a second. The joys of Teams. So we see that within this cell, we have a data frame. If I click into the formula bar, we can save our data frame. We can call it matrix because that's what we've done. We've saved a data frame here. And then with the core function, we've created a correlation matrix. Now what I can do is I can visualize that correlation matrix using a heat map. So the data input is that matrix that we just created, and I can use two additional parameters. I want to have labels on our correlation matrix on our heat map. So I'm going to set annotation equal to true. And then I'm also going to set the color type of our heat map. Since it's a correlation matrix, the cool warm option is the most common for this type of visual. So when I commit that, we see that our Python output changes from a data structure that we created, our matrix data structure. Now we have another image type. Now we have another image Python output. I can display the plot over the cell. And now we can quickly see the correlation between the numeric columns of data from within our Excel spreadsheet. We see that we have the cost price, sales price, discount, and we can see whether there's a positive or a negative correlation between them. And we can also see the strength of that correlation. If it's closer to 1, that's a very strong positive correlation. If it's closer to -1, that's a very strong negative correlation. So we've seen really quickly with just a couple lines of code, we can create a pairs plot, great for exploratory data analysis, as well as a correlation matrix and visualize that correlation matrix with a heat map. Some of this correlation stuff we can do natively in Excel, or we might have to enable an add-in to do it, like the analysis tool pack as an example. So we can do some of it, but the output is static. It's really difficult to visualize. We have to do further manipulation. With Python, as we saw, with just 2 lines of code for our correlation matrix or 1 line of code for our pair plot, we're able to very quickly make visuals that are live, connected to our data, respond to updates to our data, and look great. We can resize, drag them around, and we can do actual manipulation within those Python statements as well. So those are two sort of basic visual use cases that I want to cover. I'm going to move on to the next one, which is a user-controlled bullet chart. There haven't been any questions so far. Ken, I will ask again just before I move on. Any questions?
The only question we've got is, can you please show that again? And I'm sorry, I didn't catch exactly when it was from. So Abhishek, if there's a specific thing that you wanted to Joseph to re-show, can you just mention what it was just into the chat for us, or unmute yourself will work as well. We need Jeopardy music right now.
Okay, I know. That's okay. The next demo is a visual as well. So
okay, perfect. There you go.
Okay. So we might end up seeing the same thing again. Let's zoom in. I thought I'd increase the font size, but that's okay. All right. So we looked at some sort of basic visualizations, just a couple lines of code, and we did see that integration of Excel and Python because the data source for our visual was in Excel. As that data source changed, our visuals updated to those changes, but the visuals only changed in regards to the data within them. So the data that we were visualizing updated, the visuals updated, but the formatting of the visuals was still static. Like some of those parameters that I input previously, like I wanted the cool warm theme, I wanted annotations, all of those were hard-coded in our Python code. But we can actually have some of those parameters be user-defined and controlled within our Excel spreadsheet as well. So I'll show you what I mean. One of the visuals that we can create in Excel, we need a little bit of a workaround to do it, but we can create them, are bullet charts. I've created them in Excel before by creating like 3 stacked column charts, and then you sort of like mush them together, and you have to do some calculations within your spreadsheet to like make sure that all of your reference layers line up properly, your progress bar is okay. So it is possible. You do need to do a little bit of a workaround. It's not super complicated. It can be a little bit of a pain. We can also do that in Python with the added advantage that everything is dynamic and really cool. So the first step here is I'm going to create a data frame of what we want to visualize. So I'm going to like reference all of the data that we need. And then in the cell underneath is when I'm actually going to create my visual. The reason I'm doing it in this order, if we remember the execution order of our Python statements in Excel, it goes from top to bottom, left to right. So important to keep in mind as we're building out our multiple step analysis. So we have we're in Python here. Let's expand the formula bar. It will give us a little bit more room to work with. And this is where we can define some of this user input elements. So the first thing I want to define are the reference values for our bullet chart. And that's going to be equal to these references here. Actually, I don't need the header. Let's just go B2 to B4. Now, if we commit that, it's going to be a pandas data frame. So let's actually commit that and just have a look for now. Right, so we see that as a pandas data frame. It's just one column with 3 rows, but it is a pandas data frame. And in this case, we actually want our reference values to be formatted as a list. The reason for this is we're going to want to reference these reference values in our visual. If they were stored as a pandas data frame, our visual wouldn't work because it's expecting a list of values to format the visual. So when we reference data in Excel, by default, it's a pandas data frame. It's this tabular data set. But sometimes when we're working with different functions and functionality in Python, the input for that can't always work as a pandas data frame. So sometimes we need to update our Excel input to be lists or series or arrays that are structured in certain ways. And one of the ways we can do this is just by referencing a column within our data frame. So what I mean by this is right now we have a pandas data frame. It's just one column with 3 rows. So if I use a numeric index in square brackets, Python uses a 0-based index. So I want to return the 0 or the first column in our data frame, which does seem a little bit silly since our data frame only has 1 column in the first place, but that's okay. I'm just explicitly stating I just want 1 column from our data frame, which is the first column. And after I define that and commit that, and it loads, we see that we have a pandas series. So a pandas series is like just a 1-column slice of a data frame, if you will. When we just have 1 column of data, that's a pandas series. And a pandas data frame can even be considered like a collection of pandas series all mashed together. So pandas series will work as input for this bullet chart visual that I'm creating. So we just need to do a little bit of an extra step of converting the data type from a data frame. When things don't work in Python and Excel, I've learned going through some of these examples, it is usually the type of data structure that you have. When you're coding in Python, these things are really easy to define because you're just typing in like a list of values or like these references of 80, 90, 100 as an example. You just have to be really sure of what data structure of input is expected in a visual or a model or whatever you're trying to do in Python. You may need to manipulate that input. So we've done that for our reference values. I'm going to move on and also define our actual progress, which is equal to just cell A2. In this case, since it's a single cell, that's fine. We can leave that reference as is. And I'm also going to reference the colors that we see here. And I'm going to have to do that same trick. I just want to reference that first column. Since we have multiple rows, it's recognized as a pandas data frame. So now that I have 3 pandas series, I do want to create a data frame from these series. So I'm just going to call this data. And I'm going to create a pandas data frame. Let's do this on one line. I'm going to create a pandas data frame. The first column name is just going to be called reference. And the values of that column are our reference values that we defined. The second column is going to be called color. And the data is just going to be our colors, like that. And let's close the bracket there. OK. So now we've set up the data. We have reference values, actual progress, colors, as well as a data frame that we can use to power our visual. If we preview it, we just have this data frame that looks like this. So we can see that for our reference layers, those are the colors we want in our visual. And now it's time to actually create our visual. So rather than go through line by line and code Python, I'm just going to paste a code block in, and then I'm going to go through and explain what happens at each of the levels. So let's copy and paste that code in here. It is a big block of code, but I'll expand the formula bar and we'll go through. So when we create visuals in Python, I didn't do this in the last example just to keep the code simple and concise because there are defaults that do it for us. But usually it's best practice that we want to set the actual plot size. So here we see we have like figures we have axis. These just reference call. This gives us like the framework of our Python visual. For our first, so that gives like the blank canvas, if you will, that later on in the Python statement we're going to fill in. We're going to fill in and actually create our bullet chart visual. Now we plot our reference layers. So I've done this in a for loop programmatically. Essentially, what is happening here is that in our first layer of our reference level, we want to show between 0 and 80% completion, like for a target, if you will. This is a little bit of a special case, which is why we have an if statement in our loop. So we're saying when we start looping through our reference layers, start at 0, and we want the width of that first reference layer bar to be between 0 and it goes up to 80, or the value of that first reference layer. After that, we want our next reference layer to start at the end of our previous one and go up to the next value, which in this case is 90. So the width of that reference bar is only 10. It's the difference between 90 and 80. The first one was 0 to the first one. The second one was the height of the first reference layer to the end of the second layer. And then we do the same thing depending on how many reference layers we have until we get up to 100%. Then in this next chunk within our code, we're just visualizing our actual progress, which we see here. Our horizontal bar goes from 0 to the value of our actual progress. We've set that bar to be blue, as well as the height of our bar. And then we've set up some text. So this is going to be the data label of that progress bar. So we see that our progress is 86. All this is saying is that we want a data label on the right side in the center of the bar with white font size 10, but we just want the actual progress. And then down here, we're just setting some of the aesthetics. Oh, let's get rid of that. I think that was a mistake. We're just setting some of the aesthetics of our chart. So like we're setting what the limits of our x-axis are from 0 to 100. We're setting where we want ticks on our axis. We're removing ticks on the y-axis since we don't need them. And then we're adding a label on our x-axis. So I know it looks complicated, and the for loop probably does make it a little bit more complicated than it needs to be. But when we do that, and I add the visual here, we see that we have a bullet chart. So we have our reference layers from 0 to 80, 80 to 90, 90 to 100, and we have a blue bar with a data label here. But what's really cool is that if our progress changes at like a status update in a project meeting, and our progress goes from 86 to like 94, just typing that in the cell in our spreadsheet and hitting enter, the data frame that created our visual updates, our visual itself updates, and we see that the bar changed to be 94% now. And if we regress, everyone goes on vacation, no progress gets done, there's no updates to Monkey Tools this month, and we're now back to like 64% progress. We can update that progress as well. And now we're way back into that first reference layer, that yellow reference layer, and we can see, ooh, we're actually like quite far from target here. So all of these updates are reflected within our visual. So this progress updating is really cool. We can update our progress. But one thing I like about this is that some of the formatting of our visual, like what levels our reference layers are, we can update that too. We can make that user controlled as well, since we reference this in Excel. Like if I wanted our references, now that we've gone all the way back to 60%, maybe I want our references to be like 60, 80, and 100. So now when I update those things, we see that the data frame and the image are refreshing. Once that's gone through and updated, now those reference layers have actually updated as well. So we can see, okay, we're 64%, but we're actually out of the yellow zone. We're into the orange zone. This is good, or it's better than it was before. And in fact, if we wanted to, we can also update the colors of our reference layers as well. Like maybe if we don't like yellow and orange and red, we wanted it to be like red, yellow, and then green. We can do that. We can go red, yellow, green. Again, our data frame will update, our visual will update. We could also do this with like data validation, but we have full control over some of the formatting of our visuals, just typing into cells in Excel. We don't have to set up anything complex. It's just setting up that structure. And now we're able to track our progress, change those reference layers, as well as change like the actual color of our visual as well. And we're able to do this really with like any parameter of our visual, like with some of these with the axis titles, we could update some of these tick marks on our axis. We can control all of this directly in our spreadsheet, and it flows through to our Python visual, which I think is really cool, since we can just sort of type it in. We don't need to set anything up that's super complex, and it responds. And creating our visual, as we've seen with earlier examples, we could run a correlation and then do the output. We could do further data transformation in Python and then visualize the output. Really, we have tons of functionality that weren't available to us in Excel, or at least weren't available to us in the same way in Excel. Now we can do it with Python. And yeah, this is one of my favorite examples of pairing some of that data visualization with Python, some of those user-controlled elements, just typing it in Excel. If we're making this for our users, they don't even need to understand Python. They're just going to think it's really cool that they can type in and change some of these things, and the visual just updates. Yeah, okay. I have one more demo to get through, a classification model. I think, yeah, we're looking good for time. I think it'll be another 10 minutes or so.
Cool. Before you go on, there is a question for you in the chat, and I've got one for you as well. So okay. The first question, can we do a reference line at the end instead of a layer, red line, yellow?
Sorry, what do you mean? What do we mean by a reference line?
I am not sure. I have not seen a reference line on a bullet chart. So Gedlu, if you want to clarify that. While we're waiting for response on that one, I'm a little curious just what kind of color options do you have? I mean, are you stuck to primary colors that you can describe with words? Are you allowed to use hex codes or things like that?
Yeah, you can definitely use hex codes for sure. I just type in primary colors because I can remember them off the top off the top of my head.
Fair enough.
But we there's even, I think you can use like gold and sand, and there is a whole list of just actual named colors, which are kind of like the default colors like I've been using. But for sure, you can type in hex codes as well, and it will work exactly the same.
Nice. Mm-hmm. All right. I don't see an answer coming in on the reference line.
Okay.
I mean, sorry. Oh, yeah. Hang on.
I can explain.
Okay.
So instead of the red and yellow background, if I wanted to do a white background, we have the blue line, then a yellow tick mark, a red tick mark. Would that be possible?
When do you mean a tick mark like on the axis here, or just like a horizontal line going across a white background?
A horizontal line going across.
Yeah, for sure. This has been set up just as reference layers, but essentially where this red reference layer stops and the yellow one starts, at that point we can just set like a yellow line there, for example, and then when the yellow changes to green, we could set a green line there, or whatever color we want. Yeah, for sure we can format it that way.
That's really cool. Thank you.
Cool. You're welcome.
I think that's it. There's one comment in here about accessory color schemes as well, but I mean, I think that's just a general comment on colors. So there you go. Cool.
Absolutely.
All right, let's run on to your next one then.
Awesome. Okay, yeah. So this is the last demo of the session, and this is building a classification model within Excel using Python. So I'm using a pretty standard example data set, particularly when it comes to building classification models. If you've gone through any sort of machine learning 101, building a classification model in your language of choice, you're probably familiar with the iris data set. So this is a data set where we have 3 different types of flowers. As we see here, we have 50 rows per flower. So we have 150 rows in our data set in total. And we have 4 columns of numeric data. We have the length, the width of the petal, and the length and the width of the sepal there. So we have basic numeric data. We have a very small data set, but what we want to do is we want to build and train a classifier so that when we have new data and we don't know what the flower is, what do we think the flower is based on our classification model? And it can be one of these three flowers in our data set, or different types of irises, I should say. So I'm going to go through, and one thing I'm going to do a little bit differently. I've started doing this as we've gone through our demos, but rather than define multiple elements within our Python statement, like I could build this whole classification model in one Python script and just paste that into one cell, and it would still work and would still get like output we could refer to and stuff, but it just becomes more difficult to audit. Like you've already seen, if we go back to the bullet chart, for example, and I click on the image cell here and open up the formula bar, it's kind of gross having to, resize the formula bar, scroll up and down. We don't have great like formatting options. So sometimes it's easier to break in these great big long scripts and statements into really just into multiple different Python statements, and everything will still work. We can still reference the elements that we create. It might just make it a little bit easier for us to audit, to update, to maintain, but also with an added advantage that because we're doing this in Excel, we can copy paste them, move them around our worksheet, but also we can label them in the cell next to it. So we know exactly what's happening. We don't need to have like little comments of code. We can say, okay, in this cell, I want to define the iris data frame. And that's what I'm going to do in this cell. So in Python, I'm just going to go up to our target name. And just like that, I'm going to say, okay, this is the data set that I want to work with. I'm going to call this our iris data frame, and it's equal to these cells. And when I commit that and go back up, and it loads. I think this is Teams. It doesn't usually take quite this long to run. We see that we have a data frame, 150 rows, 6 columns, and now within this cell we have this iris data frame that we can refer to throughout our analysis. And one of the things we can do is if we just want to quickly summarize our data frame, we could do this referring to the raw data frame as well. But one thing I think is cool is now that we've stored this whole data frame just in one cell and we've called it something, we've called it iris data frame, it's now much easier to do manipulation and to summarize it. So using Python, I'm going to reference our iris data frame. And I know I did that quite quickly, but when I just start typing in IRI, we see that we have this IntelliSense of an object that we can refer to, which I think is really cool. It really just speeds up going through encoding. And I want to use the group by function. So I'm taking our entire great data frame, and I want to group by our column called target name. And after I group by, the summarization or the aggregation that I want to return is just the mean, is just the average. And when I do that to summarize this entire data set, I'm actually going to change this to an Excel value output type. Here we go, and we see that we have this spill behavior from our source cell. We can see the different types of our target names, these 3 different types of irises, each of the columns in our data set, and the average for each one. So for example, this really jumps out that for the last target, the sepal length is quite a bit higher. And we can start to see some of the differences in the averages of the columns in our data set based on what the target is, or based on the iris type it is, and this is what we're going to try and predict. So just by looking at this sort of basic summary, we can see, oh, okay, the petal length of Setosa is way shorter than the other two types of irises, so that might be significant when it comes to classifying flowers, that if we take a new flower, we have a petal length that's quite low, maybe is a good chance it's a Setosa. So this basic type of exploratory data analysis can help us form some of these hypotheses when it comes to both building, but also measuring the effectiveness of our classification model. So we have our data set. We know we're trying to build a classification model. We have a little bit of insight into our data set. And similarly to how we built our bullet chart, and we want to define, these are the user inputs that we want, like these are the different elements that we are going to use to control our visual. We can do the same thing with our classification model. So we need to define a few different things. We want to define what our target names actually are as its own list, what our feature names are as a list, and these just the names of these things will come in handy a little bit later on. And then we also want to define the actual data. So what is the data inside those 4 columns that we're going to use to build our classification model? And then what are all the values of the target that we're trying to predict, this numeric target that relates to the actual target name. So to do this for our target names, I'm just going to go in with Python. And our target names, I can use this summarized output. I could use our data set. I can use the summarized output as well. Our target names are just B4 to B6. And I'm going to call this targets. But once again, this is automatically going to store it as a pandas data frame. In this case, we don't want a pandas data frame. We don't even want a pandas series. A pandas series won't work. We need explicitly a list. So we've seen how we can convert one column data frame into a pandas series by referencing the only column in that data frame with this zero-based numeric index. So now when I return this will just be a pandas series, but we want to take this pandas series and we want to convert it to a list. So I can use the toList function on this. I can commit that. And then once I do that and it loads, oh, we get a calc error. Isn't that great? B4 to B6 targets, Excel. I am not sure why that is not working. Let's try and start it again. Target equal to this. Great. 0 to list. If it doesn't work this time, I can just hard code in the values, fortunately. OK, not sure why I'm getting this calc error. The only thing I can think of off the top of my head, I'm sort of doing this on the fly, but I have run into specifically this calc error before. We saw this when we referred to that volatile data type earlier. It's also true if you're trying to essentially put too much load into your calculation. If your workbook gets too big or your data set is too big, you can run into this calc error. My data set is still quite small, so I'm surprised that I'm running into this error. But what we can do to fix it, this still should work. But what we can do to fix it is we can just type in the actual values. I hope this isn't the case for all the other examples, but just for the sake of time, I've just defined my list in Python. Like rather than referencing data in our Excel spreadsheet, I can just define our targets list natively within Python as a list. So then when I run, so now when I run it, this should work. I shouldn't get a calc error. Here we go. We have a list. It's a 3x1 list of just these 3 elements. I'm going to try the same thing with feature names. if this doesn't work, I may just be doing it mostly in Python, but we'll try once more. We're going to set features equal to, we're just going to look at these 3 features. And then if I just did that, let's just see if that works first before I move too far ahead. I'm still getting that calc error. Okay, so something funky is going on with my workbook, which is oh, that's okay. It's sad, but you know, these things happen. So I'm just going to type in the names of the features. So the features are the names of those 4 columns from our data frame, and this is what we want to use to train our classification model. It's based on the values of these columns. We want to try and predict what the type of the new iris is for like unseen values. Unfortunately, I can't copy. Do I have them listed anywhere? I might have to, let me pull them up here. Give me 1 second. I'm just going to copy paste. Oh, isn't this great? Okay. Let's do this. Okay. And we have the width. And we have the other width as well. Okay. This should be another list. I'm hoping the other elements don't break. Otherwise, I may just refer to this raw data set here and see if that helps. Okay. So Python, now we need to define the actual data for our features. So we just defined what our feature names are. Now we want to see what is the data that goes into these columns. And so here I can go across and down like that. I don't even need to close the brackets and go back up. There we go. Okay, that one works. Great. So something weird was going on before. I'm not quite sure why, but we have our X features. We see that this is 150 rows by just 4 columns, and it's just the numeric data. And we're going to do the same thing with our Y target here. We're going to call this Y underscore target, and we just want this to equal. We just want this to be equal to the 1 column, 150 rows. I can commit that. There we go. And we have a data frame. Okay. Now when we run our classification model, this is where we're actually doing a few things. We are splitting our data into a train test split. We are building and defining our classifier, and then we're fitting our classifier onto our data. So there's 3 distinct things happening here. All of them sort of fall under building a classification model, if you will. So I'm going to put them all in the same, in the same Python script, as opposed to just building the data structures as I was doing previously. So I'm just going to copy and paste the code in here. So I have to do a few things. I have to import model selection and or I have to import train test split rather, and our decision tree classifier into Excel. All of the other data transformation and visualization I've done previously in Excel, all of those Python libraries have been preloaded into Excel for us. We can just reference their functions and functionality without needing to explicitly load them. That isn't the case for everything. So I am from scikit-learn. I'm importing stuff that's going to help us build our classification model. So the first thing we do is we import the libraries, the packages that we need. Next, I'm creating a train test split. So usually when we're building not just classification models, but any type of predictive models, I don't want to train our data on all 150 rows in our data set, because if I did that, there'd be no way to measure how effective it is on new data. So generally what we do is that we create and train our classification model just on a subset of our data. So out of 150 rows, maybe we train our classification model on like 120 rows, and we keep 30 rows as our test set, and we pretend essentially that we don't know what type of flower those 30 rows are. We use our model to predict it, and then we can compare the predictions with the actual values since we have that data already. And depending on how well it does on those 30, we can measure the effectiveness of our classifier. Now, this is a really small data set, 150 rows. Usually you'd use way larger data sets to build classification models, but this is really just to show how we can integrate this type of classification in Excel. The focus isn't really on building a classification model, so it's really just a small example here. But here is when we split our data into those training and our test sets. And we're splitting it not just into training and test set, but also the target value or the type of flower, and then all the features that we're using to predict as well. So we do that, then we build our decision tree classifier here. I save that as classifier, and then we fit our classifier on our training set, and I can save that as our trained model. So when I run this, I really hope I don't get that calc error, because if I do, there we go. We see we have a different type of output here. We have a decision tree classifier. That was a relief. I really didn't know what we were going to do if I got a calc error with that one. It would be tough doing all that by hand. And we have some, we can't see a preview of the classifier because it's not like a data structure. It's not a visual that we can output, but we do see that we have like a trained decision tree classifier here. And there's two things we can do to see the output of our classifier. We can actually see a visual representation of our classifier, of how it classifies things, and we can also get it to generate predictions on our data set. So I'm going to start with visualizing it using a decision tree plot. So I'm going to, once again, just paste some code in. So from scikit-learn, I'm importing tree because I need, from tree, I need to use the plot tree function. And we can see this takes on our trained model, which we defined in the previous cell in our classification model. And we're also inputting it some of these user-controlled elements again. So our feature names are equal to features, which is we defined earlier as a list. Our class names is our target, which we also defined earlier as a list. And in this case, this is just like a visual formatting. I just want the elements of our decision tree plot to be filled in. But once I commit that, we're going to see similar behavior that we saw with some of the earlier visuals that I created. We have this image as a Python output type. And if I click on it and I just want to output display over plots, one of the things I've run into is that this isn't a high resolution output. I'm going to do some digging to see if we can generate a higher resolution output, because when I make it big, it gets all blurry. But since I've colored it, it might make sense if I go through and explain it, even though it's really tough to read and it is fuzzy. I do apologize for that. But decision trees are read from top to bottom, and we can start to see some of the information about how our classifier works. So all of the data is contained at the top of our decision tree, or all of our training data is. And then this is where we sort of ask a question for each row in our data that is contained within this leaf of our decision tree. Is the petal length in centimeters less than or equal to 2.5 centimeters? If the answer to that question is yes, we move left down the tree. If the answer to that question is no, we move right down the tree. And we do this at every leaf node. As we go down, we ask a different question of the remaining parts of our data until our data is classified, essentially. So we can see that this orange one, just based on that one question, all of the Setosa class is contained within this leaf node. And as we go down, we see that generally the leaves of our decision tree get more green or more purple, and that means we're doing a better job of classifying those leaves are more pure. So I have shown previously how we can generate this type of output both in R and Python, and how we can integrate that into Power BI. We can do the exact same thing with in Excel now. And similarly to a bullet chart, how we can parameterize some of the options for this decision tree with user input, we can definitely do that. As we did with the bullet chart, we can do it with the decision tree. So we can say like how many layers of the decision tree we want, how strict we want to be with our classification rules. I don't have time to go through all of those different options today. But based on some of the previous examples, you get the idea that we can fully control this decision tree visual with user input in our just directly from within our spreadsheet, which I think is pretty cool. I'm just going to move this to the side for now. One of the last things we can do is we can actually get our decision tree model to create predictions. So I'm just going to paste this code in once more. So for every cell that we need to use functionality that isn't built in, Python functionality that isn't built into Excel, we need to explicitly import the library or the packages that we need. So even though I've imported decision tree classifier in an earlier cell, since we need to use a function, the predict function from there, we need to use it. We need to call that library within this Python statement as well. So it may seem a bit repetitive. This is mainly just because I've broken it into multiple pieces. If we were doing this predictions in a previous cell, then we'd only need to call that package once. But basically all I'm doing here is I'm taking our trained model and I want to run predictions on our X features. So on our unseen test data, this is what I want to run our predictions on. I'm storing it as predictions, and then when I execute that, and we wait, we get an array. And if I look at the preview, we have 150 rows, one column, and this is the numeric classification for each of the rows in our data set. So we're going to see how well our model performs. We started with Excel, we did some stuff in Python. One thing that's cool now with the output of our predictions is back in our data set, back in Python, I can say, okay, I want to return predictions. And it's going to load. And it's not going to work. And the reason it's not going to work is because we've gone back above where we've defined predictions. Oh, or has it worked now? Maybe it's worked now. Let's see as an Excel value. I've never seen it flash back to there before. Okay, good. I'm going to take all of this and I just need to cut it and paste it below where we define our predictions. Clap this down. We see that now something is happening. We're busy in all of those cells. And now we can see the numeric prediction, either 0, 1, or 2, for each of the rows in our data set. And we see that we have a mismatch in one of the rows here. So it is a true prediction. And so we've defined this in Python. We've defined our classification model in Python, but we can interact with it with Excel as well. Like if I just wanted to compare our actual label to our predicted label, we could do that for every row in our data set just with a basic Excel formula. Let's move that down there. And then from that output, I could take all the unique values and just create a dynamic array from that using the unique function. And if I wanted to see how many times are the actual label from our data set versus the predicted label, like how many times are they the same, how many of them are different, I could use a countif, like an Excel function. Our criteria range is here, and our criteria is just to the left. Let's anchor these. We can drag this formula down. And then using Excel, we can just use native Excel functionality like dynamic arrays, Excel formulas to start exploring the output of our classification model. So this really is like the integration. You see, we have 100 out of 150, we have 149 times that the actual label of our classification model matched with the predicted value once when there was a mismatch. So we've probably really overfit our model, but that's okay for this example. It's really just to show we can start in Excel, go to Python, jump back into Excel, use a combination of whatever tool are available to us to do some really cool stuff, to get into sort of that realm of machine learning, data science, classification model, outputting predictions, outputting visuals, so we can understand our classifier model, all in a spreadsheet. So with that's the last demo I have. I know we've covered a lot of ground. I know I've gone through stuff really fast just to show sort of the possibilities of using Python and Excel. But we've covered the basics. We've covered referencing different types of Excel data to bring that into Python. Some visuals, some user input controlled visuals, and we've finished off with a classification model. So thank you everyone for attending today. As I say, I know it's been a lot. If there is any questions in the chat, Ken, please let me know. But if not, thank you everyone for attending. I've had a blast, and hopefully you enjoyed it as well.
The only question that's here is related to debugging tools. Are there any debugging tools that you get for when you create errors in your Python code, such as calc error or others?
Yeah, there are different. So I guess the answer is there's not great debugging like within Excel. If you were to use the same Python code in an external tool, there's definitely better debugging tools. I would say one thing that is handy is when you get the like #Python error message, that does mean that there's an error like in your Python code. And then we see on the diagnostics pane here to the right-hand side, we do sometimes get a nice helpful error message, like when I said, okay, I want to fill in this column with predictions, but it says predictions isn't defined. So it's like, okay, I need to go and see why is predictions not defined. What is harder to troubleshoot is when we just get like a calc error. I did just have to go and look up what a calc error is and why it might be happening. There wasn't great troubleshooting for that. In fact, when I click on help with this error, it just says sorry. It apologizes. So some troubleshooting stuff, troubleshooting, I guess, more than debugging, does exist. There are some helpful errors, but not always, if that answers the question.
There you go.
Mm-hmm.
Awesome. I don't see any other questions in the chat at this point, so
cool.
Sort of the final call for those. Thanks a lot for doing this, Joseph. It's excellent. I'm now interested to see. I might have to go play with the bullet chart. That's one that for me would actually be worthwhile. Although nice. I will say this is my one concern with the whole Python thing, though, is that we still haven't got an answer from Microsoft on what it's going to cost to run Python when they bring it out of beta, and that's the right. biggest probably concern that I see with it is just not having that clarity. And it's only been out for what, 8-9 months, and they still haven't given us an answer there. Yeah. So that's the one downside. But yeah, I can actually see some useful functionality here. So thank you for that.
Awesome.
I appreciate it.
Of course.
All right.
Thank you.
And there is a question from Gedlu. Do you have any content on Python and Power BI?
I in fact do. I had a presentation at this very user group 2 years ago, Python integration in Power BI, and I will get the link to that presentation and the course files, and I can drop it in the chat.
Fantastic. Thanks, man. Appreciate it.
And I think it's on the SkillWave YouTube channel as well.
There you go. Yes, it will be, because all of our meetups are there. Absolutely. Awesome. Well, thanks again so much for doing this. I really appreciate it. You're doing double duty today for looking after the what's new in Power BI as well as the main feature presentation. Really appreciate it, Joseph, as always. So awesome. We'll sign it off for today. As I say, I'll get the recording of this posted tomorrow. So thanks everyone for coming. Don't forget to sign up for the next meetups that we have coming up, and we'll see you all next time. So till then.